Okay, so in this last section, we are going to talk about writing numbers in scientific notation. This is our learning goal, is writing numbers in scientific notation. It's our last key math skill for this chapter. And we're going to start out by pointing out a couple sort of interesting things. Humans have an average of 100,000 hairs on their scalps, okay? Well, this turns out this number is just easier to write as 1 times 10 to the 5. Now, each hair is about 0.000008 meters in diameter, right? And it turns out this number is easier to write as 8 times 10 to the minus 6. Now, I say it's easier. It's easier if you're comfortable with the notation. Surely some of you are looking at this and going, well, that's not easier. I'd rather write the zeros. Well, when you get used to it, it's going to be easier. And if we had a number with a lot more zeros in it, that might be more convincing. So let me try to convince you by showing you how to write numbers in scientific notation. So again, this is our last key math skill for this chapter, writing numbers in scientific notation. All right, so there's two parts of a number in scientific notation. First of all, there's the coefficient, and then there's the power of 10. So let me demonstrate with the number 2400. The number 2400 can be written as 2.4 times 10 to the 3, right? Where that's the coefficient and that is the power of 10. Now, you know, I'm tempted. I'm going to show you how this is actually true. This is 2.4 times 1,000. Can you read my writing? That's 2.4 times 1,000, right? That's equal to 2,400. Can you see that? All right, so the way that we did that was we took this number and we found the decimal point, which is here, and we went 1, 2, 3, and we put it right here. And then we said, all right, well, since it's a big number, that's going to be times 10 to the 3. You see I moved it 3 places. 1, 2, 3. Whoops, whoa. Moved it 3 places. 1, 2, 3. And since it's a big number, then it's going to be 2.4 times 10 to the positive 3, right? All right. So let's, I guess I just showed how I did that. Here's another example. 8.6, okay? So watch this. I'm going to do this with a different color. It goes 1, 2, 3, 4 places, right? So I can get my number that's between 1 and 10, 8.6. Right? 1 was 1, 2, 3, 4 places, right? So it's going to be 8.6 times 10 to the 4 because I moved it 4 places, but this is a very small number, so this is going to be minus 4. 8.6 times 10 to the minus 4. Okay? All right, so here's some sort of explicit examples of powers of 10. If you have 10,000, let me go, I want a bigger marker than that, okay? Let's go with 10,000. If we have 10,000, can you see that that's the same as 10 times 10 times 10 times 10? It's the same thing, right? So this is 1 times 10 to the 4, or sometimes people simply write 10 to the 4, right? 1,000 is the same thing as 10 times 10 times 10, right? And so that's 1 times 10 to the 3, right? Can you see that there's 4 tens here? There are 3 tens. There are 2 tens, 1 times 10 to the 2. There is 1 10, 1 times 10 to the 1. And there are 0 tens, 1 times 10 to the 0, right? Did you know that 10 to the 0 is equal 1? All right, that's an important thing to be able to appreciate. All right, so let's look at some more examples. Some other powers of 10 are 0.1, which is 1 times 10 to the minus 1, right? 1 times 10 to the minus 1. Or, boom, boom, 1 times 10 to the minus 2. Or, boom, 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 1 times 10 to the minus 3. No, skip that. I don't want that. What's going on here? There you go. 1 times 10 to the minus 3. Or, here, can you see that? That's 1/10 4 times, right? 1 times 10 to the minus 4. Okay? Messing with my hand here in this Sorry about that. Okay, forget that. Let's come over here. All right, so these are some examples of powers of 10 or negative powers of 10. Now let's look at another example when we would want to use scientific notation. The diameter of a chickenpox virus, right, is 3 times 10 to the negative 7 meters. And that's sort of a micrograph of a chickenpox virus. 3 times 10 to the minus 7. So you see what this is in meters? Man, really, this is killing me. Sorry. Okay, look at this. Okay. I got some setting wrong on my computer here, or my iPad, and it's making it so I can't touch the screen. I'll figure that out later. For now, let me just try not to touch it. So, look it. Okay, right? 3 meters. It's 1, 2, 3, 4, 5, 6, 7, right? And so it would be 3 times 10 to the, and since this is a small number, it's going to be minus 7. Wow, my handwriting. All right, so we'll get this figured out. 3 times 10 to the minus 7. Okay? So here's some other examples of times you might want to use scientific notation. What about the volume of gasoline used in the U.S. each year? So it looks like it's billions of liters. Billions of liters. See that? So we take this. I can't do it. My pencil's this is too small of a number, but it would be like 11. So it'd be 5.5 times 10 to the 11 liters. Okay. The diameter of the Earth looks like it's just over 12 million. So it's going to be 1.28 times 10 to the 7, right? We're just moving the decimal point over. All right, and you can see that there's some numbers we're going to be dealing with in chemistry and physics and biology that are really small. Now, 500 seconds, it might seem like a little overkill to say 5 times 10 to the 2 seconds, all right? That might not be useful. But if you're dealing with the mass of a bacterium in kilograms, yeah, you don't want to write all those zeros out, okay? All right, so let's do some more examples. This is how you do it in a calculator. I do want to spend a couple seconds on this because there's a key on your calculator, which most calculators have a key that looks like this, EE, and that is a super useful. So if I want to write 4 times 10 to the 6, I write 4 EE 6, and I get, most calculators are going to write it like that. Okay, it's gonna type out like that. That 4E06 means 4 times 10 to the negative 6. This is what this means. Okay, and 2.5 times 10 to the minus 4. So I write 2.5, and then I write EE minus the minus button. Your minus button on your calculator may look like this. Okay. Oh man. All right. Having a problem here with my touch screen. All right. So that said, I think you get what's going on here. Let me move on. We're going to do a couple sample problems. Write each of the following in scientific notation. So I'm going to do the first one first, of course, I guess, right? And I'm going to come here and I'm going to say 1, 2, 3, 4. So it looks like it's going to be 6.4 times 10 to the 4. It's positive because 64,000 is a big number, right? Now this 0.021 is a small number. So let's write this out. It's going to go 1, 2. Looks like it's going to be 2.1 times 10 to the 2, but it's a small number, right? So it's going to be 2.1 times 10 to the minus 2. All right. So I don't think I'm going to do any more of those. I think these last two are just sample problems. Those are what I just did. And let's just review the chapter real quickly, okay? This is the concept map for the whole chapter. So first of all, in section 1, we dealt with substances called chemicals. And the chemicals, we defined chemistry, chemicals, and matter. Remember that in our first conversation? And then in our second or third conversation, we talked about the scientific method. And then after that, we talked about how to study, right? How to study. And I gave some personal practical tips on that. And then the last two videos, we've been identifying key math skills. All right, so that was chapter 1. And I hope you'll go back and practice those things so that when we get into chapter 2, you're ready for that. We'll certainly have some assigned practice problems for you. So good luck.